Good afternoon, everyone. Now I explained in last videos how to connect computers between team by physical layer and identify team by MAC address on data link layer. It would be good to define a language to be able to communicate team. Data link layer, as we know, the OSI model. Each OSI model layer has one or more associated roles that are used to set up communications. But what can this data link layer be used for? The main role of data link layer is to connect machines on a local network. It allows also detection of transmission errors. In this video I will talk about Ethernet protocol and Ethernet trame. This language will make it possible to define the format of the messages that the computers will exchange, and the winner is Ethernet. In a network, we translate language by protocol to be more professional. Language in network is a protocol. Okay, Ethernet is not the only layer to protocol, but it is the most widely used today. The goal of networks is to be able to exchange information. Since we're discussing between very different machines, which team services have very different operating systems, Windows, Mac OS, Linux, we need to create a common communication language to understand each other. This is the protocol. The protocol will define what information will be sent and especially in what order. In our message, we will at least have to send the address of the user, the recipient's address, the message itself. To use, we can very well see that the first 48 characters that we are going to receive represent the MAC address of the sender, since the MAC address is 48 bits. The following 48 the address of the receiver, then finally the message. We are therefore going to position the recipient's MAC address first, followed by the sender's MAC address, also called source MAC address, and after that the protocol will therefore define the format of the messages sent over the network. More exactly, we will call this message a frame. The frame is the message sent over the network in layer 2. As we see, format of in Internet trame, you have first the MAC recipient, MAC address of a recipient, MAC address of source or a sender, and message continuation. But after that, we are therefore going to position the next. We need some specific information to understand it. You have to remember the OSI model. Okay, I will help you with a diagram. We have seen that when sending information, we browse the layers from top to bottom. We have seen that when sending information, we go through the layers from top to bottom. We therefore won't through layer 3 before going through layer 2. Layer 3 can therefore indicate to layer 2 which protocol was used in layer 3, and this is useful because in arrival when the layer 2 of the receiving machines receives the data, it says that the destination MAC address is indeed its own. It must send the information to layer 3 and therefore to the correct layer 3 protocol. It is therefore necessary to indicate in the frame which layer 3 protocol was used when the message was sent and when it crossed the layer of the OSI model from top to bottom. We have our frame therefore becomes like this: MAC DST address, MAC SRC of source, protocol of layer 3, and then message continuation. We have almost everything. Why almost? Because we are missing the essential, the information to send. We still haven't fixed the error detection problem. For the information, we'll put it right after the layer 3 protocol. In addition, we'll follow up with the error correction code, or CRC. The CRC is a mathematical value which is representative of data sum. Basically, this means that it is a number that will be different for each message. Imagine that machine A sends a message to machine B. When sending A calculates the CRC in X value and puts it at the end of the frame. B receives the message and does the same calculation as A with the received frame EY value. B compares the value she determined Y with the value that A had evaluated and set it the end of the frame X. If they are equal, bingo. If the frame sent by A is identical to the frame received by B. If there are different groups, there was an error transmitting. The frame received by B is apparently not the same as that sent by A. There was a problem somewhere, but we detected it. The full frame, we now have all the elements of the frame and therefore have the complete frame as we see. So the Ethernet trame we have is this. So I wish that you understand the Ethernet stream. In next video I will talk about the layer 3 of OSI model. Thank you for watching this video.